a priori algorithm analysis and a posteriori algorithm analysis. Of course, if you have your algorithm, you want to analyze it. That's where DSA comes in, right? That's where big O notation comes in and all of that. You want to know how this algorithm performs. How does it scale? How much time does it use? How much memory space does it use? Is it going to be good when you have larger data sets? You want to analyze it basically. And knowing when to analyze it brings us to two different approaches: a priori analysis and a posteriori analysis. They sound so nice. I love saying it. A priori, a posteriori. A priori, a posteriori. If you don't know what analysis of algorithm is, it is simply the process of evaluating the efficiency of an algorithm in terms of the resources that it consumes, majorly the time and the space. So basically, how fast does it run? How much memory does it use? And it's very important to understand how your algorithm performs. That helps you to choose the best approach for whatever case scenario that you have. If you don't know what algorithm is, you should check my video on DSA, data structures and algorithm, and you should also check my video on big O notation. You should definitely check that one on big O notation. You're going to love it. So you need to measure, you need to analyze the algorithm. You can have two algorithms, one finishes in 1 second, the other takes 10 minutes. You want to know when to decide which to use. The one that finishes in 1 second might take longer if there are larger data inputs. So you just analyze the algorithm basically. Now, that brings us to the question, when should algorithm be done? That brings us to two different approaches. The first one is a priori analysis. This is the analysis that is done before running the algorithm, and a posteriori analysis is done after running the algorithm. So a priori analysis is the theoretical evaluation of an algorithm before it is executed on a computer. We'll do it side by side. So because a posteriori analysis is the opposite of a priori analysis. So a posteriori analysis, on the other hand, is the practical evaluation of an algorithm after it has been implemented and executed. When it comes to priori analysis, you analyze the logic and structure of the algorithm to determine how it will behave in terms of time and space without actually running the code. Posteriori analysis involves running the algorithm, executing the code with actual input data to measure its real-world performance, its execution time, its memory usage, maybe its CPU utilization. How does it work? How does priori works? With priori analysis, you use mathematical reasoning and logical thinking to measure. That's where big O notation comes in. You should check out that video. For posteriori, you write the code and you run it on different test cases. Priori does not depend on programming language or compiler optimization or the computer you're using, because you're not running it, right? Posteriori depends on the programming language. For example, if you use Lisp code, Python is faster. If you use Python to write, like, your answer is kind of faster than JavaScript, right? The programming language, you take that into account when it comes to posteriori. The hardware, the compiler, the interpreter, the actual input data, you take that into consideration as well with posteriori. But we don't do that with priori, because with priori we didn't run the code. We only reasoned it out based on the structure of the algorithm. We look at the code and we're like, okay, we reason it out. Output of a priori analysis are usually measured in big O. So you probably say, oh, this algorithm uses constant time, it's O of 1. It uses linear time, it's O of n. But with posteriori, you get figures. So you can measure the time. So, we have this, we're trying to search through this. We measure the time, we run it and get the exact time. So the linear search is 2.34 milliseconds. We get that exactly. That's what our output we will look at, like with posteriori. And with priori, we use O of n. We use our big O rather. For example, we have this linear search function. And of course, we know that this is the worst case scenario will be O of n. The best case scenario will be O of 1. That is if the element is at the start. But the worst case scenario is O of n. So this is O of n. That's a priori analysis. Why this takes 2.34 milliseconds, that's a posteriori analysis, the actual time. So that makes it a posteriori analysis. Priori analysis is useful. It helps you to compare algorithms without actually running them yet. You're able to choose the best algorithm for a task. So while writing, you're able to choose without exactly running yet. And it helps you to estimate how the algorithms will perform on larger inputs. I'm writing this algorithm, I have like just 5 inputs. What if I have 1,000 inputs? What if I have 10,000 inputs? And it's very useful in the design stage during implementation. or even for implementation, rather before implementation actually. And for posteriori analysis, why is it used? It helps you to understand real world. It reveals how your algorithm would behave with real world sizes, input sizes, and it allows you to fine-tune your code based on actual results. So in this case, we have 2.34 milliseconds. We know what we got, so we're able to fine-tune. Say we want 2 seconds exactly, we're able to fine-tune, we're able to do all of it. And it's useful for comparing different implementation. Let's go over it very quickly again. We use priori before execution, posteriori after execution. And posteriori depends on data input. Priori is theological. We are talking about big O, mathematical models, while posteriori is experimental, real execution. The output of priori will usually be O of n, complexities, O of n, O of log n, but with posteriori, you have actual outputs, like 2.434 milliseconds, right? Priori helps us to compare algorithm generally, while posteriori helps us to measure real-world performance. So which one is done more often in practice? I think in real-world software development, posteriori is done more because you're trying to check how fast does this run, how much space does it use, can we optimize this part? So you probably will use posteriori more in software development, like real-world, real-life software development. But in academia, in interviews, design thinking, algorithmic design rather, priori is more common. If you're in an interview, you're probably doing more of big O and all of that. So you're expected to analyze efficiency without writing code. And big O notation helps you here. So the balanced approach would be to combine both. Start with a priori analysis to select the best algorithm theoretically. Then conduct a posteriori analysis to fine-tune performance for real-world constraints. Don't forget, priori analysis is equals to theoretical complexity, while posteriori analysis is equals to real-world execution. And both are needed for optimal algorithmic selection and performance tuning. Thinking about it, another analogy you can use is think of priori as planning your movements using Google Maps. So you see estimated time on Google Maps, right? That's priori. Posteriori, on the other hand, will be actually taking the trip and measuring the time that you use. That will be posteriori. You get it? All right. If you enjoyed this video, please don't forget to subscribe, like, comment, share, turn on notifications for more tech and coding content. See you in my next video.